Sorry about that. So my name is Behdad, and I'm here to talk about HarfBuzz at 20. This is a sequel to my talk 10 years ago at this conference. And what I'm going to talk about is about HarfBuzz, the Rust migration, a standardization of font format extensions, and a long-shot idea for extending font formats further, and if we have time, some demos. So what is HarfBuzz? Now we define HarfBuzz as a C++ platform with a C library API and accompanying command line tools for working with fonts. So the name comes from a Persian literal translation of OpenType. And so to quickly walk you over what features we support, the shaper is what people mostly know HarfBuzz as, and the shaper's job is to make sure you can read on screens or in print in every language, every script, and every font. But HarfBuzz also has a lot of integration layers with other libraries like FreeType, glib, Cairo, platform libraries. There's a font subsetter and variable font instancer that is very useful for web font serving and optimizing font sizes to reduce them. And we have Draw and Paint API, which allow extracting the outline of fonts, monochrome and color fonts from the font to pass it to your own rasterizer. And this year we added 3 rendering libraries, a rasterizer, a vectorizer, and a GPU renderer. And if we get time, I'll demo those. So HarfBuzz was started in 2005 as a cross-desktop Linux text shaper. I started a rewrite in 2006, which is what we now call HarfBuzz. The rewrite was written in C++ and heavily relies on operator overloading and templates to reduce code duplication. It has a stable C API ABI. It hasn't changed in 20 years. It's replaced 3 open source text shaping engines in GNOME, Qt, and ICU. And since 2017, the shaping has been complete, and we have been expanding in other areas. It has a very low bus factor. I'm the main developer. Khaled Hosni is the maintainer, and we have about 3 domain experts that work on it part-time. So I get this question a lot, that wasn't HarfBuzz just a text shaper, and why are we adding all these rendering and other features in it? Well, the reason is that HarfBuzz's internal code base has this efficient binary data reading infrastructure and description of pretty much all font tables, so it makes a lot of sense to reuse the infrastructure for other purposes. And we have an extensive configuration system, so if you want just the shaper, you can trim it down. It will compile to 300 kilobytes, and you can embed it in WASM or anywhere you want. We actually, this year, added a single file compilation module called HarfBuzzWorld.cc, which is also a URL for our online demo site. So what I wanted to make with HarfBuzz in retrospect is that market share is very important, because when HarfBuzz was only a Linux shaper, it was very buggy, and we didn't even get bug reports enough for these complex scripts or complex fonts. So gaining market share is what made me go from Red Hat to Google. We want to embrace open source and make the license as permissive as possible to help adoption. We established it as industry standard for text shaping. And if we do our job right, nobody should notice. Performance, agility, robustness, correctness, and we also leverage HarfBuzz as a platform to experiment with font format extensions. HarfBuzz now shapes majority of text on screens thanks to Chrome and Android, among others. Open source, all of the open source operating systems, browsers, desktops, applications, and a lot of programming languages even use it. even in .NET API these days. The Wine emulator remains the only other open source shaping implementation that we know of. And even proprietary companies like Google, Adobe, Microsoft, Amazon, all of them use HarfBuzz one way or another. Figma, Canva, Instagram. So to make sure HarfBuzz renders text correctly, initially our job was to match Microsoft's implementation, which was the de facto standard of what OpenType is. We tested the first 10 years of HarfBuzz, we tested it extensively against Microsoft. And we decide to diverge only when we decide that Microsoft implementation is buggy and we can diverge from it. But we try to follow this rule of 2 out of 3. If Microsoft and Apple differ in a feature, we try to side with one of them, or sometimes we try to improve on both. We have over 6,000 shaping tests, and it's heavily fuzzed by Chromium, OSS Fuzz, Firefox, independent researchers. So thanks to billions of users, HarfBuzz is established as its own standard now. Font designers test their systems on Chrome, test their fonts on HarfBuzz, and we get bug reports in time, and people design their fonts to work with HarfBuzz. So then in the past 10 years, we started adding new features, and one of these features, which was a collaboration with Microsoft, Adobe, and Apple, was the variable fonts in 2016. A variable font, the left side of the screen, we have these like multiple fonts, different font files. A variable font allows for encoding all of those in a single font and allows for a range of arbitrary range of weights and widths and other font properties. Then in 2018, we added a subset library. A subsetter is the piece of software that allows for breaking down a font into a subset of the features. For example, a subset of the characters that's supported, and is extremely useful for web font serving. So for example, you have a Latin font family that has thousands of characters in it, but if you're only interested in English subset, you can cut a subset from the binary font. That would be a fraction of the size. Then in 2021, as a collaboration with Microsoft and others, we added Color V1 feature to OpenType. Color V1 is the first piece of technology that can render emoji as a vector font with features like gradients. Basically, we can source SVGs and convert them to a font. Sorry, I have to correct myself. SVG and fonts existed before, but they are not implemented in major platforms for valid reasons. So we shrank the SVG feature set down to a binary format and encoded it, and that's why you can see highly zoomed up emoji. So the last 5 years, I spent a lot of time optimizing HarfBuzz. This was mostly driven by Chromium's desire to hit better benchmarks. So for example, for some fonts, you can see that we increased performance from anywhere from three times faster to 7 times faster. And this is on the OpenType performance and AAT. So it's an ecosystem of bindings and ports. We have the C++ platform with the C API as the main code base. There's HarfRust, which I'll talk about next, which is a high-fidelity Rust shaper port. There's Vue HarfBuzz as Python bindings, and there's HarfBuzz.js for JavaScript and WebAssembly, and a whole bunch of other ports that we don't officially support and other people maintain. And now, talking about Rust, Rust has been taking over the C++ and C space, and we wanted to address safe shaping. So there's a history of attempts. In 2017, HarfBuzz RS was developed by the Servo team as a high-level safe API to the HarfBuzz C++ C library API. Then 2019, we saw All Source, which was YesLogic's clean room implementation. Basically, they hired someone to document shaping based on HarfBuzz code base, and then they implemented based on those documentation. But it's it's incomplete and mostly used within YesLogic itself, although it's open source. There's RustyBuzz, which is 2020 Razor Falcon fully safe port of HarfBuzz to Rust based on the TTF parser create to load font tables. And then 2021 Chad Brokaw, another prolific Rust font engineer, wrote his own shaper from scratch. But then in 2024, we started, Chad and I together started a fork of RustyBuzz as a solution to rule them all out. So Google Oxidize is a project started in 2022 to unify the font compilation and font usage from C++ and Python all into one Rust code base. And as part of that project, HarfRust is the shaping solution to that problem within that project. The reason HarfBuzz forked Razor Falcon's RustyBuzz, I've got to mention, is that RustyBuzz was unmaintained, and there was desire from the Oxidize team to port it away from TTF parser onto the Foundations crate, so that's why we agreed to fork it. So the name, funnily, is another Persian transliteration joke that HarfRust means true type this time. So it sounds like we're going backward. So RustyBuzz and HarfRust initially had performance that was 2, 3, 4 times slower than HarfBuzz. And last year we worked on bringing performance down from 4 times slower to just about 20% slower on a variety of benchmarks. This is OpenType. This one is AAT. Again, for Lucida Grande, we went from 4x to less than 20% slower across a bunch of benchmarks. And then the status is that HarfRust now fails only 12 shaping tests out of the 6,000 in HarfBuzz test suite. It's used already by a bunch of Rust solutions like Parley and Blitz. Chrome is experimenting using HB HarfRust, the bridge between HB and HarfRust. It's a work by Dominic, and the performance is very promising so far. We are working on bringing performance on par with HarfBuzz. And eventually, Chromium wants to port to HarfRust natively, skipping the bridge that we are currently using. And Servo experience by Nico Burns, he added a HarfRust backend to Servo and kept the HarfBuzz backend as well, and wrote some code to compare the output of the two shapers and report any discrepancy. So that has been also very helpful in finding small bugs. And now I want to talk about standardizing font format innovations. So back in mid-2010s, when I was at Google, I figured that we source open source fonts. We write our own font compiler. We have the operating system and browsers to use the fonts, and font shaping and rendering libraries are all open source. So the bottleneck is the font format itself, and if we can extend the font format, we can innovate in ways that are not possible otherwise. So in 2022, I wrote a set of proposals. One is called AVAR2 that can save up to 70% in some Latin fonts. The other one is Vark, which can save up to 90% in Hangul and 70% in Chinese, Japanese fonts. These are file size reductions. And the other one is Beyond 64K, which is for mega font families like Noto that want to have one font file that implements all of Unicode. Because fonts are currently limited to 64K shapes per font file, and we want to break that limit. So the path to innovating the font format is normally going through OpenType, but OpenType is property of Microsoft, and you can extend it unless Microsoft is committed to do that. But what you might not know is that OpenType is also mirrored in an ISO standard called ISO Open Font Format, which has its own slow process for change. And we started the ISO pad in 2022, and it's still not released as a standard. So the other challenge that we face is that Google Chrome is reluctant to ship features that are not in major other browsers or are not standardized. And in October 22, Apple already shipped the AVAR2 feature that I proposed, but Chrome only shipped it 2 months ago. So that's a 3.5-year standardization tax that we have to pay while Microsoft and Apple ship their own extensions and standardize or release it later. And then I want to talk about the long-shot idea that I've been circulating for 4 years, and that's WebAssembly in the font. And why? The current code versus data boundary is quite arbitrary. We have the layout engine run some code and pull the data out of the font to drive the layout. We have the higher layout, paragraph layout, page layout, all of the work with code, whereas the font data is still data. And what I want to do is securely inject programmability into the font file itself, and that will serve as a generic solution to many hard shaping, text shaping problems we face. For example, in Arabic, proper shaping with OpenType is really hard. Positioning is impossible currently. For many smaller scripts, the same. And the nice thing about this is that then if we do this, we don't need to make a specific shaper changes any longer. The shaper just becomes this container for logic that the font ships. And there's a lot of precedent in other areas of computing, the best being moving from OpenGL fixed pipeline to programmable pipeline, or you can see it in moving from a static HTML serving to dynamic servers and to edge computing. You can see it from HTML to JavaScript. So programmability has been explored everywhere else in computing, and it can be done securely. Put it another way, it's a plugin system for the shaping engine, and we can use it to work around the standardization problem. And the status of this, I developed a proof of concept in HarfBuzz back in the days, 4 years ago. And Graphite is another text shaping model and design and library that is not widely deployed, but I was able to put Graphite WASM into a font. The payload was only 90 kilobytes. And we have a bunch of demos that I get to if we have time. And there were also a few unexpected demos. Someone put a full LLM inference engine into the font. Another one made a typewriting machine learning font. Someone else put a translator machine learning engine into the font, so you type in English and it displays in German. So maybe I quickly do a couple demos and then we can go to questions. Okay. So the first demo I want to show is the HarfBuzz World website. This is where you go, and there's a guide for how to embed HarfBuzz into your embedding project. There's more resources in the bottom. And then this is the shaping demo. You can pick a font from presets or load your own font, put the text in. This is the shape displayed using HarfBuzz, and you can get the graphing clusters here. For example, here we see that for the emoji in the middle, there's 6-7 characters that the shaper combines into one shape. So it's useful for debugging as well. There's a subset demo which can subset a full font to the text that you have typed, and in this case we see that the subset saves 99% of the size to be able to display just this string. There's the raster demo. You see just the same thing because it's rasterizing to an image and displaying. And the vector demo does the same as SVG or PDF. The PDF output particularly is very useful in applications like LibreOffice that can print color V1 emoji as vector to their PDF output by embedding the glyph PDFs into the document PDF. And then there's the GPU demo, which is my favorite. And this is a small demo, and I load the full one. The slug algorithm is a text rendering technique that was designed by Eric Langiel 10 years ago. And just a couple months ago, Eric released his patent on the algorithm. So 2 weeks later, with the help of AI, I implemented a full open source implementation of it in HarfBuzz and released it as a HBGPU module. So this is what it can do. You can infinitely zoom in and out. You can do rotations. And thank you. And it works with WebGL and WebGPU. If the browser supports it, you can upload your own font and set your own text. And again, here with the emoji, it does the same, infinitely zoomable color emoji. And so, and each page has a code snippet for how to use HarfBuzz for that feature. So that was the first demo. And then I have here the HarfBuzz WASM examples repo on GitHub. There's demonstrations of various features. For example, I said Arabic position is kind of impossible in OpenType. This is an OpenType rendering of this without any mitigation. You see the dots overlap each other or overlap the glyph. This is the best effort OpenType with thousands of OpenType rules to move the dots around and avoid overlaps. This is the WASM with a small piece of code to do optical positioning, and you see that if you know Arabic, you know that this is the desired rendering, and these spaces here are redundant. We have Egyptian hieroglyphs are interesting because when you see the sequence, they combine in a recursive box model, and the OpenType way to do it, again, includes thousands of rules. With WASM, it's just 5 lines of code. That I skip. This one is network. It takes the code and randomly glitches it. This is Arabic Roga script. So this is the OpenType rendering. This is the WASM rendering, which aligns each cluster vertically by their optical center. This is a calculator font. This is called Inception. It's pretty cool. It's by Simon Cousins. And what you see here is that it takes a font, rasterizes it internally in WASM using FreeType, then generates outline to render it like this, pixelated. And with variable font technology, you can change the pixel size even, and weight and slant and everything. So it's pretty cool. This is a handwriting font. Again, what it does is internally it loads a regular font, but then traces it with dots. And you can move the dot spacing. This is bubble kern, which has an idea to optically kern things based on these bubbles around them. And again, Llama TTF is the LLM inference engine. There's another bunch of them here, Translate TTF and Handwriter TTF. And that's the demos, and with that, questions. Thank you.
Thank you very much, Behdad. 20 years we are talking about an author himself walking us through from 0 to 20. It's crazy timeline. So, questions?
What do you see as the future of better support for different languages and scripts? Do you think we're almost there in terms of font features? Will WASM solve all the remaining gaps, or are there other things to contribute to the standard, the format?
So shaping has been pretty much a solved problem since 10 years ago, except for things like Arabic, where Arabic basic reading, of course, works, but if you want this calligraphic styles, we are really far behind. And there's efforts, different efforts to address that by extending the format, but again, if we try to solve this positioning problem with a data-based approach, it's going to be really hard. A lot of complex logic to standardize, whereas my opinion is that that complex logic should be just compiled and put in the font, because there's no one algorithm that supports everyone's needs. Yeah.
Hi, thanks. Great presentation, and a fan of your work. I just want to understand the co-working with Skia now, like with Skia's new backends like Graphite and others, have they impact on the font shaping part? Or like going forward, how do you see HarfBuzz as also a rasterizer versus Skia doing some part of this work, how it coexists?
Right.
Thanks.
So Skia text module uses HarfBuzz as its backend already, but Skia is a big rasterizer, and the HarfBuzz rasterizer is really very nimble and small. And the reason we wrote it is there are a lot of game engines and other like mobile apps that can use a small rasterizer. So it's not going to compete with things like Skia or FreeType. One reason is that we don't support any hinting, whereas game engines or apps who are already pulling HarfBuzz can now switch to rasterizer instead of having to also pull in FreeType. That was the motivation.
I noticed that your performance charts had Arabic script and Devanagari on there, and browser performance testing looks at like English, Latin script, Cyrillic Russian, and Japanese. And then on one hand, would it be like a good thing or a bad thing if we had Arabic script and Devanagari in browser benchmarks? Like, would it be good for getting like those scripts go faster, or would it have bad incentives? Like previously, we've seen a situation where Firefox had Latin ligatures turned on by default, and Chrome, for performance reasons, had Latin ligatures turned off. So, like, would it be good for Arabic and Devanagari scripts to have them on performance, browser performance, or would like cause incentives to like turn off these Arabic script features that you're working on?
Yeah, that's a good question. I think it would be a good idea to include them, and the fact that they are not included is something we have already noticed, because a lot of times when we work on these Arabic or Devanagari performance gains, they don't show up as any improvement in browser metrics. Would it incentivize people to break Arabic? I don't think so. Like, all of the OpenType and AAT shaping is accepted by all browsers that they are required features these days. The WASM that I'm talking about is extremely experimental idea that might never actually ship in browsers, but for the basic shaping needs, every browser supports it, and I don't see the test suite break give them bad incentive about that. Any last one, or we are over time?
We have time for one more question. Anyone? All right. Then